Hello everyone. I'll start with communication system, and in communication system we will be starting with analog communication, and in analog communication we will be starting with amplitude modulation. So all of you must be aware of communication system as a chapter as a whole, in which we study digital communication, analog communication, and various other techniques for modulation, and also random variable information theory. My objective, my um, method of teaching would be such that you are able to score good marks in ISRO. So most of the things will be only related to ISRO and not GATE. So for getting the max out of it, you need to watch the videos properly, and also you can also increase the speed to 1.5 or 1.75, because it takes time in writing things. But when you are watching a video, you can easily grasp things when the speed is high. So in amplitude modulation, basic is I won't be talking about a lot of definition and theoretical part of it, but more about the conceptual and the formula based things that will be required in ISRO exams. And these things that I have formulated are on the basis of previous year questions. So you'll be able to solve all the previous year questions and also all the formula related questions that will be coming in future. Um, amplitude modulation is changing the amplitude of a carrier signal according to the message signal. So first of all, I'll talk about some of the basic things that you would require. So let us assume a message signal empty, and let its Fourier transform look like this: m of f. This signal can be a sinusoidal signal, this can be a square signal, this can be any type of signal in your exam. But the only thing that you'll require to do in all the things that I'll derive is to replace empty by that particular signal. If it is a sinusoidal signal, replace empty by sinusoidal signal. If empty is a square signal, replace it with a square signal. If it is a triangular signal, replace it with a triangular signal. So let us assume that we are passing this empty from multiplier having multiplication with AC cos 2 pi fct, which is the carrier signal. So what will happen to empty? It will get multiplied. It is simple: AC cos 2 pi fct. But this is not important. What is important is how the graph of empty will change if it is multiplied by cos. So first I'll talk about simply what will happen to cos. If you have a signal cos 2 pi fct, do you know how to represent its Fourier signal? In Fourier transform, this is represented by impulse signal at plus fc and at minus fc. This is its Fourier transform. It is simple. Only two impulses, and the amplitude is 1 by 2. 1 by 2. If you want to find the reason for it, it would be simply that cos 2 pi fct can be written as e j 2 pi fct minus e to power minus j 2 pi fct divided by minus the sign upon 2. Take it Fourier transform, you will get this. Simple. But I am assuming that you have a basic knowledge. I'm only here to tell you the things that you will require for ISRO exams. Okay, so you have two impulses at plus fc and one at minus fc. So after getting these impulses, the basic things you will know is that if you multiply two things, so this is the message signal, when it is multiplied by this signal, what will happen? This signal will get shifted to plus fc and minus fc. So if this was fm, this would now become fc plus fc plus fm by 2, fc minus fm by 2. Simple. This is the only thing that we require to know. So we move the signal from So how I used to remember it, whenever you are multiplying any signal with cos, pick up that signal, place it at the carrier frequency, place it at the frequency of the cosine signal. Simple. I will tell you once again. So this is the signal. This is kept at the origin. It can be any signal. This can be a sinusoidal signal. This can be a square signal. This can be a triangle signal. Pick this signal. Keep it at the carrier frequencies of the cosine signal. Simple. So you don't have to think much. Only pick up the signal and keep it at plus FC and minus FC. But one thing that ISRO had been doing in the past is that they never give multiplication with the cos signal. They give it with the sine signal. And one mistake that everyone does is they do the same thing, but they don't remember that in sine, the part that is moved to the negative side is also inverted. So if this is the message signal and it is multiplied by a sinusoidal signal having a carrier frequency 2 pi fct, it would be moved to, so steps are same. Pick up this signal, place it at plus fc. But if you are multiplying it with sine, pick up that signal and place it at minus fc, but with also reversing it. This is the most important thing, and most of your uh, AM related questions will be easily solved if you know this. So let me tell you the reason. If you need to find the reason for it, it is simple that here you are multiplying by 2 pi fct. The signal here is minus, so whenever it will be multiplied, the negative will remain with it and amplitude will reverse. Okay, so the next important thing is, you know about the cosine multiplication, multiplication with the message signal. uh, the other important thing that comes is the low pass and band pass filters. Low pass filter and the band pass filter. So what is a low pass filter? What is a band pass filter? Low pass filter is a filter that passes a frequency less than a cutoff frequency. Band pass filter is a filter that passes a particular range of frequency, and similarly a high pass filter passes a frequency higher than a particular cutoff frequency. But most of your requirement will be solved from low pass filter and band pass filter. So low pass filter and band pass filter questions are solved like, you have to draw the graph like we had been drawing it, and all the signal that passes through that particular part will be transmitted, and the part that is not transmitted will be left behind. Okay, so I will tell you, like, this is the signal that you have received, and you have a low pass filter which has a cutoff frequency of 10 kilohertz, but your signal starts from 20 kilohertz. So what will happen? All the signal before 10 kilohertz will be passed, which is 0, so you will obtain nothing. And similarly, if you have to pass signal between 20 kilohertz to 40 kilohertz, you pass it through a band pass signal which is from 20 to 40, and your signal will be passed. Simple. The other important thing that everyone get confusing is how to find the bandwidth. Me myself had so much issues finding the bandwidth. So the technique I used to follow was that what you have to see is check how much signal is towards the right from the origin. So if this is 20 kilohertz, 40 kilohertz, so you have to only check the amount occupied only on the right hand side. So how much is the bandwidth? 40 minus 20, 20 kilohertz. Okay, so you might have understood this. Now I move to simple amplitude modulation techniques. These had been some basics that you will require further. So amplitude modulation. talking about amplitude modulation, the most important thing is that is the carrier is being modulated according to the amplitude of the message signal. The one which is changing is the carrier. Sorry, I had an issue with the network connection. I'm resuming it. So amplitude modulation. So CT is the carrier signal, MT is the message signal. So let CT be AC cos 2 pi FCT. So what will happen is that we want to change the amplitude of the carrier signal with the message signal. So AC is directly proportional to MT. This is the basic thing that you must know. AC is directly proportional to MT. So if AC is equal to Ka into MT, where Ka is the amplitude sensitivity. Amplitude sensitivity. Then the amplitude modulated signal should be Ka MT cos, because AC is replaced by KAMT cos 2 pi FCT. But if you know that this is not the amplitude modulated signal, but the amplitude modulated signal is 1 plus KAMT cos 2 pi FCT into AC. So what is the reason behind this thing? Why is 1 plus KAMT? And the simple answer to this would be that this is the equation for envelope detector. If your detector being used for amplitude modulated signal is an envelope detector, then you would require this type of message signal, modulated signal. So 1 plus KAMT cos 2 pi FCT. So why we are using this shifted version? This is the shifted version. It is shifted by 1. Why 1? So I'll be telling you about the envelope detector. I'll tell you in short for some basic explanation that if this is your signal, how envelope detector works is it moves like this only for the positive part. So your signal should be in the positive direction completely if you want to detect the complete signal. So for moving this, we add 1 so that it moves to the positive direction. Okay, so this is the basic equation. AM signal, amplitude modulated signal, is represented by AC 1 plus Ka MT cos 2 pi FCT. Okay, so this is the basic equation of an amplitude modulated signal. Now I'll be telling you some of the basic things that you need to know. So 1 plus Ka AM, in this Ka into MT, the message signal can be anything. It can be a sinusoidal, it can be a square signal, it can be a sawtooth signal, it can be a triangular signal, it can be anything. So if Ka into maximum, which is the maximum value of MT, is our mu, which is modulation index. Modulation index. So this can also be written as AC 1 plus mu into MT, the remaining empty signal cos 2 pi FCT. So can you tell me what will be the maximum value of AC cos 2 pi MT? This if this sorry AM cos 2 pi MT, if this is the message signal, it would be Ka into AM. This is the modulation index. Mu is equal to K into AM. Similarly, it can be found for if this is the triangular signal, the maximum value will be multiplied by Ka. That would be your modulation index. If this is the square signal, the maximum value will be multiplied by Ka. That would be modulation index. I hope you are able to understand this. So now we'll talk about its Fourier transformed version that I will be talking in the next video. Okay, so I think you have understood some basics of amplitude modulation. Now we'll move towards some of the complex things in the next video. Thank you.